Hello guys, um, welcome to my YouTube channel, and in this video we're gonna be doing theorem number 4 in most textbooks, and it doesn't really matter what number it is in whatever textbook. What matters is that we have to prove that angles that are in the same segment are equal to one another. So for instance, in this question, in this theorem rather, we've been given the circle ABCD with the center O, and then you're going to be required to prove that angle A is equal to angle B. So this is one of the most easy theorems because it's just a spin-off of the theorem number 2. So if you guys can go with me, let's quickly prove that angle A and angle B are indeed equal to each other. So without wasting any time at all, we're going to make ourselves a construction. We're going to construct something. So we're going to say construct. So you're going to join OD and OC. Okay, so my black marker is really not doing justice to my work. So let's make our construction. We'll make our construction like that. Remember, it has to be in broken lines to show that it is something you are adding. It wasn't initially included in the question. So that's why we use broken lines. So as you can see, after the construction has been made, we can now begin with the proof. We're gonna say this. We're gonna say D angle OC, meaning this angle here, is equal to twice angle A. So as you can see, D angle OC, which is this angle, it's the angle at the center, and then angle A is an angle at the circumference, and they are subtended by the same arc DC. So we're gonna say angle at center is twice angle at circumference, like that. So in mathematics, we do not use full words or complete words. So we'll say D angle OC, that's the angle here, that's the angle at the center, is twice angle A, that's the angle at the circumference. And then we're gonna come back and say the same angle, D angle OC, that's this one, the angle at the center, is equal to twice angle B, because angle B is found at the circumference, just like angle A was found at the circumference. So D angle OC is twice angle B, like that, and then we'll give the same reason. We'll say angle at center is equal to twice the angle at the circumference, like that. So with that being said, ladies and gentlemen, because D angle OC is twice angle A, and at the same time D angle OC is twice angle B, we can then conclude, we can say therefore 2a is equal to 2b. Why? Because these are both equal to D angle OC. And then we're going to divide both sides by 2. And these 2 and these 2 cancel. These 2 and these 2 also cancel. Therefore, making angle A equal to angle B. So that's the end of the theorem. That's the proof of the theorem. So now, what's very important for you to realize every time you are given this theorem is that whenever, so you have to know this, like we are done proving the theorem. If you need to prove this theorem, this is the only thing you have to do. You make a construction and then you say D angle OC is twice angle A. The same angle, D angle OC, is twice angle B. Therefore, 2a is equals to 2b. As you can see, 2a is equals to 2b. Why? Because they are both equals to D angle OC. And then you divide both sides by 2, then angle A is equal to angle B. That's the end of the theorem. But every time you are given a circle, I hope I'm gonna draw a nice circle. Yeah, so every time you are given a circle and you are having things like this, you are having this butterfly shape. Let's say we can call this P, Q, R, S. So you have to know all the time that angle Q and angle R are equal, and angle P and angle S are also equal. We can write it down like this. We can say angle P is equal to angle S, and angle Q is equal to angle R. So why is this true? The reason for this, the reason for both of this is gonna be angles in the same segment. So every time you see such in an exam, always remember, as long as these points, these 4 vertices touch the circumference, you always have to remember that the angle here at the circumference is equals to the angle here at the circumference, because they are both subtended by the same arc. And the angle at this circumference is equals to the angle at this part of the circumference, because they are subtended by the same arc as well. So the reason for this theorem is angles in the same segment. So that's it from me. I hope this helps you navigate Euclidean Geometry grade 11. So if you like this video and if you'd like more content like this, please subscribe to my YouTube channel and give me a thumbs up. And you can also ring the bell just to make sure that you are one of the people who get the most recent content that I post on this channel. So until next time, guys, bye.